Hello, welcome back to Aliens of Space Education. My name's Andy, your host of this brilliant series. Carrying on through season 2, we're now looking at an amazing planet. We're going to go a little bit more detail than we did in season 1. We're looking at the mysteries of Mercury, the swiftest planet in our solar system. It's kind of small, kind of fast, but it's an intriguing planet in our solar system. It's rapid orbit around the Sun to its mysterious surface, its features, and its role. Its surface features and its role in the early formation of the solar system. And we're going to explore that. So I really hope you enjoy. If you have any questions, please email me. Please go to my website, spaceforalleducation.com. Look for me. Please get in touch, like and share. That's all I can ask. Okay, so let's get into Mercury. To start off with, let's talk about Mercury's position in the solar system. Mercury is the closest planet to the Sun. Its orbiting average distance around the Sun is about 59.7 million kilometers or 36 million miles. This proximity to the Sun means Mercury experiences extreme temperature variations more than on it. More on that later. So Mercury is, even though it's really, really close, it's still 60 million, just under 60 million kilometers away from the surface, which means that's why it's not falling into it yet, because it's still a long way away. Okay, Mercury's orbit is highly elliptical, meaning it's not a perfect circle. The elliptical orbit combined with its fast speed gives Mercury unique characteristics. It completes a full orbit around the Sun in about 80. That's less than 3 months for it to go around the Sun just once. Imagine having a birthday every 3 months. You'd have thousands of presents. On top of that, Mercury has a much slower rotation on its axis, so it's rotating really, really slowly, taking about 59 Earth days to complete one rotation. Remember, we rotate once every 24 hours. This takes 59 days to do one day, and the year is 88 days long. So, in theory, you only have one day and one night a year. That's a lot. This creates a strange situation where one day on Mercury, from sunrise to sunrise, lasts 176 Earth days. So it's longer than one rotation. From sunrise to sunset, 59 days, because it's so slow at rotating. It means that for every 2 Mercurian years, there's only one Mercurian day. Talk about a long day at the office. Could you spend a whole year working at the office and never going home because the day is that long? No, you need to come home. You need to get some rest. So Mercurian days is very, very long, which makes it really cool. But I wouldn't want to live there. I like it here. So that's Mercury's space. So now let's look at the physical characteristics of Mercury. Now that we've established where Mercury sits in the solar system, let's dive into what Mercury's actually like as a planet. What's it like on the surface? What's going on there? Mercury is the smallest of the 8 planets. Its diameter is about 4,880 kilometers or 3,032 miles. It's small. To put that into perspective, Mercury is slightly larger than the Earth's moon. Despite its size, Mercury is incredibly dense, second only to Earth in terms of density. So it's very close, but it's very dense. This high density suggests a large metallic core, just like Earth has a metallic core, which accounts for about 85% of the planet's radius. The core is 85% big. Scientists believe that this core is rich in iron, making it one of the most iron-rich bodies in the solar system. So if we know there's no life there or anything like that, there is a tiny, tiny chance that in the future we could go and mine that iron and bring it back to create bigger, better spacecrafts, because it's been under so much treatment from the sun could have properties in it that make it really, really good for us to use to make new materials. So it's something we can look at in the future. But what about the surface? The surface is heavily created, meaning it gets bombarded by meteors, rocks, and all sorts of things. It resembles our moon. If you look at the moon and you've got a good telescope, you can see it's got lots of craters on it. Mercury is very similar. The planet doesn't have a sustainable atmosphere to protect it from impacts. Just like Earth, we have the ozone layer and the magnetic field around us. When a meteorite goes past, we see it burning up and leave a trail behind it. Mercury doesn't. If it's going to hit you, it's going to hit you to protect it from impacts. So it's bombarded by asteroid comets over the billions of years that we know that's been around. The most prominent feature on Mercury's surface is the Caloris Basin, one of the largest impact craters in the solar system. It measures 1,550 kilometers or 960 miles in diameter. Remember, the whole of Mercury is 4,800 kilometers, and this takes up 1,550 kilometers. That's nearly a quarter. Over a quarter of the planet is in one massive crater. Wow. This impact was so powerful it caused weird terrain on the opposite side of the planet due to the seismic wave travelling through the planet. What's the best way to describe this? If you hit something here and there's no dent here, there could be a bulge here. Shockwave has gone through the planet and bulged out the other side. That's what makes Mercury really strange. It's created a weird impact. You've got to think that's a massive, massive crater. Creates out nearly a quarter to the side. Another intriguing feature on Mercury's surface is the presence of the lobate scars, which are essentially massive cliffs formed by cooling and contracting of the planet's interior over time. These scrapes can reach heights up to 3 kilometers or 2 miles and can stretch hundreds of kilometers. This shrinking phenomenon suggests Mercury is still cooling and contracting even today. That means when you screw up a ball with paper, you get all the little rough bits and everything like that. If you squeeze it even more, some of those ridges point out, and this is what's happening to Mercury. It's still shrinking, but some of these bits on the surface are sticking out and going, no, I'm not going that way. I want to stay up. But the surface is still going so, but some bits are still sticking up. They're only a couple of miles high, but that's still really, really high. That's large. Now let's not forget the temperature extremes on Mercury. Now the surface, you've got to remember, it takes so long for a day. That means the temperature is going to be facing the sun for a long period. Due to its lack of significant atmosphere to retain heat, temperatures can swing from one extreme to another. In the daytime, so when we're facing the sun, just like on Earth when we have the sun up, it can soar to 430 degrees Celsius, a lot hotter than boiling water, or 800 degrees Fahrenheit, while at night it can plummet as low as negative 180 degrees C. So it goes from 430 degrees C to a freezing cold minus 180 degrees C, or negative 290 degrees Fahrenheit. That's a range of 1,100 degrees Fahrenheit or 610 degrees C. It drops 600 degrees Celsius just by turning from day to night. That will freeze your bone. You have to be really careful. You have to wrap up. You have to be sunbathing 1 minute, and the next thing you'll be covering yourself in a really, really thick blanket because you'll be shivering. So we've got to make sure we protect ourselves. This makes Mercury not just the coolest planet in the solar system, but it also has one of the most extreme environments in the solar system. Now, because it's so close to the sun, the atmosphere, it could have a very, 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 very thin atmosphere. Because it's so thin, we haven't seen it. But it means that if there's any wind or anything like that, it's not going to last very long because the temperatures are so drastically changing. There's no rain, there's no ice, there's no nothing. It's just really, really hot, then really, really cold. You've got to be careful where you are. Mercury's magnetic field and internal structure. So moving on, let's discuss something that has puzzled scientists for quite some time. Maybe you can help us figure it out. Mercury's magnetic field, unlike Venus and Mars, Mercury has a magnetic field. Although it's very weak, only about 1% the strength of Earth's magnetic field, the existence of this magnetic field suggests Mercury's core is at least partially molten metal spinning round. Something is happening in the core, in its own core, creating a magnetic field, and we don't understand it. But here's a catch. Given Mercury's small size, science expected that the planet's core would have solidified long ago. It should be solid. The fact that it hasn't, and this is still a subject of ongoing research, so we're still looking at it today in 2024, 2025. Some theories suggest that the sulfur in the core could be creating an antifreeze, lowering the melting point of the core material, allowing it to remain in a liquid state. The interaction between the molten core and the planet's magnetic field is what generates a weak magnetic field. But why is it so weak compared to Earth's? It's still being studied. So we know it's creating a magnetic field, we know it's there. But how? Why? Why is it so weak? Why is it not stronger? We don't know. We're studying it. We're trying to find out. And we need your help. Maybe you could come up with an experiment. Email it to us. See what we can figure out. It'd be really cool to hear your thoughts on this. Mercury's atmosphere, or lack thereof. Now let's talk about Mercury's atmosphere. Or more accurately, its exosphere. Mercury has what's called an exosphere, a thin layer of atoms and molecules that are blasted off its surface by the solar winds, by the sun, micrometeoroid impacts, and the planet's own heat. Unlike Earth's atmosphere, Mercury's atmosphere does not provide any protection or support life as we know it. It's more like a thin veil of particles that are constantly getting replenished, then blown away into space. The only way I can describe this to you about Mercury's atmosphere is if you put a ball in water and you take it out, all the water runs off it and gets pulled down and it's gone. Imagine that where that water's gone is in space. What's lifting it up is the sunlight hitting it and pushing all that water off the surface. It's all running off, but because the water, some of it will stick to the bottom, as Mercury rotates, that water will then get into the sunlight or get to the top and then run off again. And that's what's happening in Mercury. Because it's moving, this water is always moving around the planet and freezing when it's on the cold side because it's minus 180 degrees C. It turns in the sun, it melts. And solar winds are pushing some of it away, but not all of it. So there could still be a tiny thin layer of atmosphere there, but it's really, really minuscule. The main components of Mercury's exosphere is hydrogen, helium, oxygen, sodium, calcium, and potassium. Wow, that's a lot in the atmosphere. These elements are so sparse that we couldn't breathe. or support life. It won't support us. It's too thin, and it won't support life as we know it. So if there is life, it has to survive in a very limited atmosphere. The exosphere is so thin that atmosphere within it rarely collide, which is why it is not considered a true atmosphere. Because the atoms don't collide with each other to create new elements or anything like that, and it's constantly changing, it's not called an atmosphere, it's called an exosphere. Interestingly, though, the presence of certain elements like sodium and potassium that have been detected in the exosphere has surprised us. That shouldn't be. How did they come about? These elements are easily vaporized, yet they're still there. And their presence suggests the surface is constantly being bombarded by solar winds, which knocks these elements into the exosphere. So the winds are really banging into the planet and create the dust and the atoms to come back up. The study of Mercury's exosphere gives us clues about how planets interact with solar environments and provide us with insight into space weathering process that occur in airless bodies like Mercury and the Moon. So by studying Mercury, we can help understand the Moon and how we can potentially live there, because how the solar winds affect it helps understand how those solar winds are going to affect the Moon to make it easier for us to live on there. But the atmosphere is still really, the exosphere it's really thin. It's not a real atmosphere. But because it has potassium, it's really strange and it's not right. Where does the sodium come from as well? Interesting. Exploration of Mercury. Next, we're going to take a look at how we're going to explore, how we have explored Mercury to come up with these answers so far. Given Mercury's proximity to the Sun, Mercury is a difficult place to study, but that hasn't stopped us from trying. We are a species of ingenuity, and we're intrigued, and we want to learn. So we keep trying to get there, so we keep doing it. The first spacecraft that travelled to Mercury was Mariner 10, launched in NASA 1973. Mariner 10 was the first spacecraft to use gravity assist maneuver, which allowed it to fly past Venus, then Mercury multiple times. So it used Venus to get a gravity assist. During its 3 flybys, so it flew by Mercury 3 times, Mariner 10 mapped 45% of Mercury's surface and discovered its magnetic field, which was a major surprise at the time because we didn't know about it. It's the first time we've gone there with these scientific instruments and we looked at it. We didn't go back until 2004 and we launched then Messenger mission, Mercury, surface, space, environment, geochemistry and ranging. Messenger. It entered orbit around Mercury in 2000. It launched in 2004. It got there in 2011 and provided us with a wealth of information. Its Messenger was in orbit for 4 years. It mapped the whole entire surface in high resolution, studied the magnetic field, and even discovered water ice in the permanent shadowed crater at the planet poles. How the monkeys is their water ice permanently in the craters, in the shadows, underground, on a planet that gets over 4,000 degrees hot. Sure enough, the heat would have melted it, but it hasn't. It's still there. Another surprising find, given the extreme temperatures we discussed earlier. So these things, we're still getting confused by this. How are we discovering water ice on a planet that has 4,000 degrees? Yes, it freezes to 183, but wouldn't the ice turn to steam and then disappear into space because there's no atmosphere? What's keeping it trapped? Why is it still cool in there? Why isn't the heat reaching it? It's really strange. The exploration didn't stop there. European Space Agency, in a collaboration with JAXA, the Japanese Aerospace and Exploration Agency, launched the BP Colombo mission in 2018. At the minute, it's currently en route to Mercury and expected to enter orbit in the planet in 2025 this year. The mission consists of two spacecrafts, the Mercury Planetary Orbiter and the Mercury Magnetic, Spheric Orbiter. Together, they will study the planet's surface, its magnetic field, its exosphere, the interior, and building on the discoveries made by Marina 10 and Messenger. So it's taking what we already know and it wants to go a little bit deeper. It's going to be in orbit for a long time, and we're hoping that we can learn a lot more about Mercury. Maybe, just maybe, at the poles, because there's ice water, it may be safe to actually live in caves underground on Mercury and be able to survive, grow plants there, and have a little colony there and have a little party. But we don't know. We're going to have to discover that. Hopefully, this new mission will tell us more. So, what are the mysteries of Mercury? Despite the data we've gathered, and we've discovered a lot, but we've still got a lot to learn, Mercury still holds many mysteries. One of the biggest questions is about its origins. Why does Mercury have an iron core relative to Earth? There are a few theories. One suggests that in the early solar system, Mercury may have been a larger planet. At one stage, it could have been bigger. A massive collision could have stripped away much of the rocky mantle, leaving behind its dense, iron-rich core. Another theory poses that intense solar winds during the Sun's early years might have blown away the lighter material from Mercury's surface. Another theory is Mercury wasn't there a billion years ago. It came in later on. It's a trapped comet or something. Who knows? Another mystery involves Mercury's hollows. These are irregular depressions on the planet's surface that appear to be bright and thought to be relatively young. Science believe these hollows could be areas where volatile substances have sublined or turned from solid to gas, leaving behind these strange features. Think about you have a bucket of sand or a bucket of clay, shall we say. A bucket of clay is more solid. You surround it with a ice cube. So you put an ice cube in the clay, you heat up the clay, the ice cube melts, and it leaves a hole. That's what they're thinking here, leaving behind these strange fishes. But exactly what these volatiles are and how they behave under Mercury's extreme conditions is still unknown, because obviously if it's created a tunnel system or something like that, because Mercury gets hit by all sorts of things from the sun and all sorts of things from space, why haven't these cave systems or these hollows collapsed? Why are they still there? What's going on? What's holding them up? How are they so strong? Lastly, the biggest mystery that we're still trying to figure out is the presence of water ice at Mercury's poles. This raises intriguing questions. How did the ice get there? How does it remain stable in such a hostile, hot environment? The current theory is that the ice water was delivered by comets and formed through chemical reactions with solar winds. The permanent shadow craters at the poles are the only safe haven from the sun's intense heat, allowing the ice to persist. So because these holes are permanently dark, they don't get hot enough. But as you know, heat travels. It travels up, and therefore it could melt it, but it doesn't. This is really, really, really weird. And we need to discover it. So hopefully these new missions will figure it out. So let's go a little bit about them. How we, as a human species, appreciate Mercury. The planet is named after a Roman god. Mercury is the messenger of gods, known for his speed and agility, fitting for the fastest planet in the solar system. Yeah, I think so. He's super fast. In ancient Greek mythology, the equivalent was the god of Hermes. He was also embodied with similar traits. Hermes was extremely fast as well, wing shoes. Mercury's visibility in the skies has made it a significant object in various cultures throughout history. Ancient Sumerians associated with the god Nabu, the god of writing and wisdom. Chinese refer to Mercury as the hour star and associated with water, one of the five elements in Chinese philosophy. Even today, Mercury's name is synonymous with speed, communication. Think of the word Mercurian to describe someone quick and changeable. Mercury is quick. It's changing. It's weird. It's unusual. It's hot and then it's cold. Mercury is strange. And that's really, really. As we conclude our journey today, it's been a fantastic journey of just discovering Mercury. Find that this tiny, swift planet is more than just a scorched ball of rock. Its extreme conditions, strange features, and many questions have raised about the formation and evolution of our solar system make Mercury a planet of immense scientific interest. We are still learning about Mercury. With upcoming missions like the BP Colombo, with such we're sure to uncover even more about this mysterious world in the years to come. Mercury may be small, but has a big story to tell. A story that continues to unfold as we explore the cosmos. And as we discover more, maybe we'll learn more. But maybe we'll get more questions that we can't answer. Have you thought about that? The thing about science and astronomy is we learn all the time. With baby steps in studying astronomy, we've still got a lot to learn. But every time we discover something new, it brings up 100 more new questions. And the same is going to happen with Mercury. As we learn more about it, we're going to have more questions. This is where your studies are important today to help us tomorrow to answer these questions, because you may know something we don't. You may be able to think outside the box and say, what we should do is this. This is why you're important. This is what's important to us today. So I really hope you've enjoyed this little spotlight on Mercury today. I hope you've enjoyed. Please make sure you subscribe, rate, review. In our next episode, we're exploring Venus, the hottest planet of our solar system, and discovering the mysteries of its thick, toxic atmosphere. Until then, keep looking up, stay curious, and I really, really hope you enjoyed today's exploration. Take care.